The morning of December 17th, 1944, snow-covered hills near Mannheim, Belgium. Lieutenant Colonel Walter Richardson gripped the edge of the ditch as German flares floated down through the darkness, illuminating the chaos unfolding before him. In the eerie light, he watched a low-slung German tank swing onto the highway and slip into the long column of retreating American vehicles. Then another, Panthers, their distinctive sloped armor unmistakable even in the flickering shadows. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. What Richardson didn't know was that tucked into the ammunition racks of abandoned Sherman tanks just meters away were rounds that would fundamentally alter the psychological calculus of armored warfare on the Western Front. Rounds containing tungsten carbide cores capable of transforming American medium tanks into legitimate threats against German heavy armor at ranges that Panzer crews had been trained to consider safe. The M93 high-velocity armor-piercing round represented more than improved ballistics. It represented a violation of everything German tankers had been taught about American capabilities and the invulnerability of their own armor. The story of how a specialized ammunition type shattered German confidence and forced a complete reassessment of tactical doctrine begins not in the frozen Ardennes, but in the rolling hills of Lorraine 4 months earlier, where American ordnance officers were about to distribute 6 rounds per tank of an ammunition type so scarce that tungsten shortages limited production to barely 6,000 rounds per month. In late summer 1944, the United States Army faced a crisis that threatened to undermine the entire advance into Germany. The M4 Sherman tank, backbone of American armored divisions, was encountering German tanks it could not reliably defeat from the front. The Panther, Germany's answer to the Soviet T-34, combined a powerful 75mm high-velocity gun with 80mm glacis armor sloped at 55 degrees, creating an effective thickness of approximately 140mm that proved nearly impenetrable to standard American tank guns. American intelligence had catastrophically underestimated both the quantity and quality of Panthers that would be deployed. By June 1944, when Allied forces landed in Normandy, 38% of German tanks in the theatre were Panthers. Not the handful predicted, but hundreds of these advanced medium tanks, often crewed by inexperienced soldiers, but protected by armor that conventional American tank guns could not penetrate frontally at any practical combat range. The 75mm M3 gun that armed most Shermans in Normandy could not penetrate a Panther's frontal armor at any distance. The round would simply ricochet off the sloped glacis plate, leaving the Sherman crew vulnerable to return fire from the Panther's powerful gun, which could destroy a Sherman from over 2,000 meters. Even the improved 76mm M1 gun, which began reaching units in July 1944, struggled desperately against Panther armor. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Using standard M62 armor-piercing capped rounds, the 76mm could penetrate 109mm of armor at 1,000 meters at 0 degrees obliquity. This proved sufficient against the Panzer IV and many German assault guns, but the Panther's sloped frontal armor remained effectively immune. The 76mm could penetrate the Panther's gun mantlet, but only at extremely close range, typically under 100 meters, a distance at which the Panther's advantages in firepower made engagement suicidal for American crews, who understood the mathematics of their disadvantage with brutal clarity. The problem was not the gun itself, but the ammunition it fired. American ordnance engineers had recognized this deficiency and developed a solution that would arrive in Europe just as German forces prepared their largest counter-offensive of the war. The deployment of the 76mm gun itself had been a saga of bureaucratic hesitation and belated recognition that would haunt American tank crews for months. The first M4 Shermans mounting the 76mm M1 gun rolled off production lines in January 1944. These M4A176 Shermans arrived in Britain on April 10, 1944, with 130 tanks delivered to prepare for the Normandy invasion. Yet, despite their availability and the desperate need for improved anti-tank capability, American commanders refused to deploy these improved tanks on D-Day. The reasons were multiple and would prove costly. Crews lacked adequate training time on the new weapon system. Logistical concerns about maintaining two different ammunition types complicated supply planning that was already stretched to its limits. Most critically, commanders believed the 75mm gun would prove adequate for the expected opposition, a miscalculation based on intelligence estimates that proved wildly optimistic about German tank deployments. This proved to be a catastrophic error in judgment. By early July 1944, field reports from Normandy painted a grim picture that could no longer be ignored. On July 2nd, complaints about the 75mm gun's ineffectiveness against German armor reached General Dwight Eisenhower. His response, documented in multiple historical accounts, captured command-level frustration with an intensity that subordinates would remember for years. "You mean our 76 won't knock these Panthers out? Why, I thought it was going to be the wonder gun of the war." The full exchange, as recorded by witnesses, continued with stronger language, expressing his anger that ordnance had assured him the 76mm would take care of anything the Germans had. The reality confronting American tankers told a different and far more dangerous story. A board convened on July 12, 1944, determined officially what tank crews already knew from bitter experience purchased with their lives. Standard American weapons could not defeat Panthers frontally at combat ranges. General Omar Bradley immediately ordered the 76mm Shermans rushed from Britain to the front, acknowledging implicitly the magnitude of the earlier miscalculation. On July 25, 1944, during Operation Cobra, 102 M4A, 176 tanks made their combat debut. The initial engagement reports were sobering even as the offensive succeeded. While the 76mm represented an improvement over the 75mm, it still struggled against Panther frontal armor at typical combat ranges. Sherman crews quickly learned they needed to maneuver for flank shots or target the Panther's gun mantlet at close range, neither option being tactically desirable when facing a tank that could destroy them from 2,000 meters away while they closed to effective range. The solution to this tactical nightmare lay in metallurgy and physics, rather than simply mounting larger guns. By July 1944, American ordnance engineers had developed the T4 round, later standardized as the M93 HVAP. High-velocity armor-piercing ammunition represented a fundamental departure from conventional armor-piercing design philosophy that had dominated tank gun development since the First World War. The projectile consisted of a tungsten, carbide core, one of the hardest materials available to wartime industry, surrounded by a lightweight aluminum body and ballistic windshield. This design concentrated the projectile's kinetic energy into a smaller, denser penetrator while reducing overall weight, allowing for dramatically higher velocities. The result was nothing short of revolutionary for crews who had grown accustomed to tactical disadvantage. The M93 round achieved a muzzle velocity of 1,036 meters per second compared to 792 meters per second for the standard M62 round. This 244 meter per second velocity increase translated directly into penetrating power that changed the tactical calculus. At 1,000 yards, approximately 914 meters, the HVAP round could penetrate 178 millimeters of flat armor at 0 degrees obliquity, according to official War Department testing data. Against vertical armor, this performance was exceptional. The Tiger's frontal hull armor measured 100 millimeters thick, and its frontal turret similarly measured 100 millimeters. In theory, HVAP could defeat these armor sections at 1,000 yards when striking at favorable angles. The gun mantlet with its curved cast steel presented a more complex target, varying from 100 mm thick on early OSF-E variants and increasing to 120 mm on later production models, with some sections reaching 200 mm in the most heavily protected areas. But the reality of combat was never as simple as test range data suggested. The Tiger's armor, while not sloped like the Panther's glacis, was rarely presented at perfect 90-degree angles during actual engagements. German training emphasized angling the hull to maximize effective thickness, a technique called the Mahlzeitstellung that could increase frontal protection to 180 millimeters. Effective. More critically for HVAP effectiveness, the subcaliber tungsten penetrator performed poorly against heavily sloped armor, where the small diameter projectile tended to shatter on impact rather than penetrate. Nevertheless, the introduction of HVAP meant that for the first time, American 76mm armed tanks could engage the Tiger's flatter armor sections from ranges beyond point-blank distance. The mantlet suddenly became a viable target for Sherman crews at 500 to 700 meters, instead of requiring suicidal approaches to under 100 meters. This represented a psychological transformation as significant as any tactical advantage, fundamentally altering how both American and German crews approached engagement. But the development of HVAP represented only half the solution to American armor deficiencies. Production was another matter entirely, complicated by global supply chains and competing demands for strategic materials. The T4 round depended on tungsten carbide, a strategic material imported primarily from China, which produced 36% of global tungsten supply before the war. Tungsten was critical to numerous war industries, with machine tools, armor-piercing ammunition for multiple calibers, armor plate hardening, and various industrial processes, all competing for limited supplies that could never satisfy all demands simultaneously. American tungsten demand for HVAP ammunition alone consumed hundreds of metric tons annually. Each 76mm HVAP round contained approximately 0.8 kilograms of tungsten carbide, meaning a Sherman carrying just 6 rounds required nearly 5 kilograms of this scarce material. When multiplied across thousands of tanks and tank destroyers, the total demand became staggering. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. China produced approximately 10,000 metric tons of tungsten concentrates in 1944, but this had to serve all Allied needs across all applications. The United States supplemented Chinese imports with domestic production from limited deposits in Colorado, Nevada, and California, but total availability remained constrained throughout the war. The bottleneck was not American manufacturing capacity, but access to raw materials that could not be expanded through industrial effort alone. Germany's tungsten position was far worse, deteriorating steadily as the war turned against the Reich. Swedish imports declined sharply as neutral Sweden grew increasingly unwilling to supply the losing side, and domestic German production remained minimal. By 1945, German factories desperately hoarded tungsten for machine tools needed for aircraft engine production, while Panther and Tiger crews received only standard ammunition. This disparity in access to strategic materials would prove as decisive as any tactical innovation. The United States Ordnance Department had been testing HVAP projectiles since spring 1942, but production at scale did not begin until after the Normandy landings revealed the extent of the Panther problem that intelligence had failed to anticipate. The first shipment of 2,000 rounds arrived by air transport in August 1944, flown to France to bypass slower sea shipping that might take weeks to deliver critical supplies. Distribution prioritized tank destroyer battalions first, under the doctrine that dedicated anti-tank units would make best use of the scarce ammunition. Sherman tank battalions received lower priority initially, a decision that reflected pre-war doctrine but failed to account for the reality that American tanks encountered German armor more frequently than the specialized tank destroyer units that were increasingly employed in artillery support roles, rather than their intended anti-tank mission. By September 19, 1944, when the first HVAP rounds arrived with frontline Sherman units in Lorraine, the average tank had received perhaps 3 to 6 rounds. Production constraints meant that even as late as February 1945, the average 76mm tank had received a total of only 5 HVAP rounds, meaning an acquiring rate of approximately 1 round per month per tank. For crews facing German armor, this meant HVAP was reserved for targets that absolutely required its penetrating power, fired only when standard ammunition had failed or when the target demanded immediate neutralization. September 19, 1944. The fog-shrouded fields near Arracourt, France, Lieutenant Colonel Creighton Abrams of the 37th Tank Battalion watched through his gunner's periscope as German tanks materialized from the morning mist. The 113th Panzer Brigade had penetrated American outposts and was driving toward Combat Command A headquarters, where Colonel Bruce Clark had precious few forces to stop them. Captain William Dwight, liaison officer between CCA and the 37th Tank Battalion, had spotted the column of Panthers while driving between command posts in his jeep. He immediately returned to warn Clark, who realized with growing alarm how perilous his situation had become. Clark had only a platoon of M18 tank destroyers and artillery in position to stop an armoured thrust that could overrun his headquarters within minutes. The tank destroyers under Lieutenant Edwin Leiper raced to establish blocking positions on Hill 246, approximately 800 yards from the village of Réchicourt-la-Petite. They arrived just as the first Panther emerged from the woods at the base of the hill. Sergeant Stacy's destroyer opened fire immediately, striking the lead tank with its first shot. A second Panther fell to Stacy's gun within moments. Then a third. German tanks scored a hit on Stacy's Hellcat, wounding the crew but leaving the vehicle mobile enough to withdraw. The morning fog that shrouded the battlefield provided both concealment and confusion. German units advancing without adequate reconnaissance blundered into American positions they had not anticipated. Poor tactical deployment exposed the Panther's weaker side armour to flanking shots from Shermans that used the fog as cover to manoeuvre into favourable positions. Within hours, 11 Panthers burned on the approaches to CCA headquarters, stopped by a combination of tank destroyers, Sherman tanks, and self-propelled artillery firing over direct sights at point-blank range. For American crews, this engagement represented vindication of tactics developed through bitter experience in the hedgerows of Normandy. Manoeuvre, superior tactical intelligence, and exploitation of terrain had defeated numerically superior German armour equipped with technically superior tanks. But something else had changed in the calculation that both sides were beginning to recognize. Some of the Sherman tanks engaging Panthers that morning carried HVAP rounds in their ammunition racks. Not many, perhaps only a handful of rounds per tank, but enough that American gunners knew they possessed ammunition that could defeat Panther mantlets at ranges that had previously required suicidal approaches. This knowledge fundamentally altered how American crews fought, making them more willing to engage German armour directly rather than solely relying on flanking manoeuvres that exposed them to concentrated fire during positioning. The psychological impact on German crews was equally significant and more insidious. Panther and Tiger crews had been trained to engage American armour at ranges exceeding 1,000 metres, confident that their frontal armour provided near immunity to American guns. Field reports from September and October 1944 began reaching German armoured units, describing instances where American 76mm guns had achieved frontal penetrations at ranges that should have been safe. These reports, fragmentary and often confused by the chaos of combat, nevertheless conveyed a disturbing message. American tanks were no longer helpless targets that could be engaged with impunity at long range. German tactical doctrine had emphasized exploiting the Panther's superior range and armor to destroy American tanks before they could close to effective distance. If American guns could now penetrate German armor at medium ranges, this entire tactical framework became questionable. Intelligence assessments prepared for German armored units in late 1944 specifically warned of a new American shell that significantly increased penetration against Panther tanks. One German Army document from this period, captured and translated after the war, discusses the significant effect of this new ammunition and recommends increased caution when engaging American armor. The report notes that American tanks should no longer be considered helpless at medium ranges, a remarkable admission that contradicted years of training and tactical doctrine. For German Panzer crews who had operated with considerable confidence behind their armor, this intelligence represented a psychological shock. The Panther and Tiger had been designed specifically to outrange and out-armor Allied tanks, providing German forces with qualitative superiority to offset growing numerical disadvantages. If American ammunition technology had eroded this advantage, even partially, the implications for German tactical doctrine were profound and deeply unsettling. The reality was more nuanced than either side fully understood at the time. HVAP performed exceptionally against flat armor at favorable angles, but struggled against the heavily sloped glacis armor that made the Panther so formidable from the front. The subcaliber tungsten penetrator, being smaller in diameter than the gun barrel, could shatter when striking heavily angled armor rather than penetrating cleanly. This meant the Panther's glacis plate remained largely immune to HVAP at most combat ranges, while flatter armor sections like the mantlet became newly vulnerable. The Tiger presented a different target profile entirely. Its armor, while thick, lacked the extreme sloping of the Panther's glacis. The frontal hull and turret presented relatively flat surfaces, where HVAP could achieve penetration at medium ranges when conditions were favorable. The variably thick gun mantlet remained problematic, with heavily protected sections still immune even to HVAP, but thinner areas became vulnerable at ranges approaching 500 to 700 meters rather than requiring point-blank shots. This partial effectiveness was sufficient to fundamentally alter the psychological dynamics of armored warfare. German crews could no longer assume absolute invulnerability at medium ranges. American crews gained confidence from knowing they possessed ammunition that could threaten German armor under favorable circumstances, even if those circumstances remained relatively rare, given the scarcity of HVAP and the tactical challenges of achieving clean hits on small vulnerable areas during combat. The Battle of Arracourt continued for 11 days, from September 18th through September 29th, 1944. Combat Command A, heavily outnumbered by German 5th Panzer Army's 262 tanks and assault guns, defeated 2 Panzer brigades and elements of 2 Panzer divisions through superior tactics, intelligence, and use of terrain. American air superiority, exercised by P-47 Thunderbolts that claimed 73 tanks destroyed by air attack alone, played a decisive role that German forces could not counter. When the fighting ended, German forces had lost 118 Panther tanks, 101 Panzer IVs, and 122 tank destroyers and assault guns in the Arracourt sector during September. American losses totaled 151 M4 Sherman medium tanks, 49 M5A1 light tanks, and several dozen M10 and M18 tank destroyers. The exchange ratio, while favorable to American forces, reflected the reality that numerical superiority and tactical advantage mattered more than individual tank quality in determining battle outcomes. But the true significance of Arracourt lay not in the statistics of destroyed vehicles, but in the demonstration that American tank units could defeat German armored formations through combined arms coordination and tactical excellence, even when equipped with theoretically inferior tanks. The availability of HVAP ammunition, while limited, contributed to this success by reducing German advantages in armor protection and allowing American crews to engage with greater confidence at medium ranges. German after-action reports from Arracourt reveal a pattern of tactical caution that had not characterized earlier Panzer operations. Unit commanders reported increased hesitation to engage American armor at ranges that had previously been considered safe. Crews described American tanks as more aggressive and willing to fight at distances where German armor protection should have provided decisive advantage. This shift in American tactical behavior, enabled partly by HVAP availability, imposed psychological costs on German operations that tactical manuals had not anticipated. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The distribution of HVAP ammunition expanded slowly through autumn 1944 as production increased and shipping prioritization improved. By November, when 5th Panzer Army launched its counter-offensive toward the Ruhr River that would culminate in the Battle of the Bulge, approximately half of the 2nd Armored Division's Shermans mounted 76mm guns. These tanks could penetrate a Panther's front belly plate at 300 yards using HVAP, and at 200 yards had approximately a 1 in 4 chance of penetrating the front slope plate, still poor odds, but infinitely better than the 0 chance offered by standard ammunition. The division's tank destroyer battalion had received the new M36 destroyers mounting 90mm guns, which could reliably defeat both Panther and Tiger armor at combat ranges when firing standard ammunition. This combination of improved tank guns with limited HVAP availability and dedicated tank destroyers with heavier armament provided American forces with anti-armor capabilities that began approaching parity with German forces, though still requiring tactical skill and favorable circumstances to achieve success. When German forces launched their massive counteroffensive through the Ardennes on December 16, 1944, they committed substantial armored reserves, including at least 150 Tiger II heavy tanks. The American forces that absorbed this attack included units equipped with 76mm Shermans that carried HVAP ammunition, though still in desperately limited quantities. The average tank that participated in the Battle of the Bulge possessed perhaps 5 to 6 HVAP rounds, carefully hoarded for targets that absolutely demanded their use. Lieutenant Colonel Richardson's experience at Mannheim on the night of December 24th exemplified both the tactical challenges and psychological transformation wrought by HVAP availability. When he and Captain Maxwell climbed into an abandoned Sherman to engage approaching German tanks they believed to be Tigers, they understood that a 76mm gun-firing HVAP could penetrate a Tiger's frontal armor at close range, approximately 500 meters or less. This knowledge, purchased through months of combat experience and tactical analysis, meant they were willing to engage rather than simply withdrawing in the face of heavy German armor. The reality proved more complex when their target revealed itself to be a Panther, whose steeply sloped glacis armor presented a far more challenging target than the Tiger's flatter surfaces. The distinction mattered critically, as HVAP performed far worse against the Panther's angled armor than against the Tiger's vertical plates. But the willingness to engage, the confidence that their weapon could threaten German heavy armor under favorable conditions, represented a fundamental shift from the helplessness that had characterized American tank operations in Normandy just 6 months earlier. This psychological transformation extended throughout American armored units by late 1944. Crews that had landed in Normandy in June, often feeling genuinely apprehensive about facing German armor, had evolved through sustained combat and improved equipment into forces that approached engagements far more confidently. HVAP ammunition alone did not create this transformation, which resulted from accumulated combat experience, improved tactical doctrine, better crew training, and growing familiarity with German equipment and tactics. But the availability of HVAP, however limited, contributed meaningfully to improved morale and tactical confidence. For German Panzer crews, the inverse psychological pressure steadily accumulated through autumn and winter 1944. Intelligence reports warning of improved American ammunition capabilities created uncertainty about armor protection that had been considered reliable. Field reports of American tanks achieving penetrations at unexpected ranges undermined confidence in tactical doctrine. The cumulative effect was a demonstrable increase in tactical caution, slower engagement, decision-making, and general reluctance to take risks that earlier in the war would have been considered routine. The strategic implications of HVAP development extend to broader questions about technological competition in modern warfare and the crucial importance of industrial capacity over theoretical technical sophistication. Both American and German research establishments possessed competent engineers and sophisticated understanding of ballistics and armor penetration. Both recognized the value of tungsten carbide ammunition early in the war. Both developed functional designs that achieved similar performance parameters when tested on ranges. The critical difference came down to industrial capacity and resource availability, rather than scientific knowledge or engineering skill. American industry could produce HVAP in quantities sufficient to influence battlefield outcomes meaningfully, though never enough to fully equip all units or eliminate the scarcity that plagued distribution throughout the war. German industry could barely produce enough tungsten ammunition to conduct testing, much less supply frontline units in quantities that affected tactical operations. This pattern repeated across numerous weapon systems throughout the war, revealing fundamental truths about industrial warfare that transcended individual battles or specific technologies. Germany developed sophisticated and often technically superior weapons across many categories, but could not produce them in quantities that affected strategic outcomes. American industrial capacity produced less sophisticated but highly effective equipment in overwhelming numbers that proved strategically decisive, regardless of theoretical performance comparisons. The M4 Sherman was objectively not the best tank of World War II, by most technical measures used to evaluate armored fighting vehicles. But American factories produced approximately 49,324 of them, compared to approximately 6,132 Panthers produced by Germany. This 8-to-1 production ratio, combined with ammunition improvements like HVAP that reduced the technical gap without eliminating it entirely, proved strategically decisive in ways that individual tank versus tank combat results could never overcome. The post-war careers of veterans who fought at Arracourt and throughout the European campaign reflect the enduring impact of these combat experiences on military thinking and doctrine development. Lieutenant Colonel Creighton Abrams, who commanded the 37th Tank Battalion at Arracourt with distinction and later led the relief effort that broke German entrenchments surrounding Bastogne during the Battle of the Bulge, rose to become United States Army Chief of Staff, the highest position in the service. General George Patton, who observed Abrams throughout the European campaign, offered an assessment that became legendary within the armored force community. "I'm supposed to be the best tank commander in the Army, but I have one peer, Abe Abrams. He's the world champion." This praise from Patton, himself considered one of history's greatest armored warfare commanders, reflected Abrams's ability to consistently exploit the relatively small advantages of speed and reliability that American tanks possessed to defeat German forces that enjoyed superior armor protection and gun performance. The lessons Abrams learned about combined arms warfare, the critical importance of crew training, and the absolute necessity of adequate ammunition influenced his entire career and the doctrine he helped develop over 3 decades of service. Abrams commanded armored units at virtually every level from company through corps during his career, gaining intimate understanding of how tactical decisions at lower levels affected strategic outcomes. His experience with HVAP ammunition, recognizing its potential while understanding its limitations, informed his approach to military technology throughout his career. The M1 Abrams Main battle tank, named after him in 1980 following his death in 1974, was deliberately designed with principles learned through World War II combat experience. The tank mounted a powerful 120mm smoothbore gun, capable of firing sophisticated ammunition types, including depleted uranium penetrators that serve functionally the same role HVAP served 4 decades earlier. The emphasis on ammunition effectiveness as a critical component of tank design directly reflected lessons learned when tungsten carbide rounds partially overcame German armor advantages in 1944 and 45. The M1's design philosophy prioritized reliability, maintainability, and ammunition effectiveness over absolute armor thickness, recognizing that modern anti-tank weapons made invulnerability impossible, regardless of armor protection. This approach directly descended from World War II experience, showing that operational availability and ammunition quality mattered as much as armor protection in determining combat effectiveness. The tank's gas turbine engine, while unconventional, provided reliability and power characteristics that would have been familiar to Sherman crews who valued mechanical dependability above theoretical performance specifications. German veterans of Panther and Tiger units who survived the war and later joined the West German Bundeswehr brought different but equally important lessons shaped by their experience. They had personally experienced the limitations of possessing technological superiority without the industrial base and logistics infrastructure to support it effectively. German tankers had operated vehicles that were technically superior to most Allied tanks, but required constant maintenance, consumed fuel at unsustainable rates, and lacked spare parts necessary to keep them operational. Bundeswehr armor doctrine during the Cold War emphasized quality and training, while explicitly recognizing that West Germany could never match Soviet numerical superiority in tanks and armored vehicles. This realistic assessment reflected wartime experience, showing that technical superiority alone could not overcome massive material disadvantages. But Bundeswehr planners, informed by wartime experience including encounters with HVAP ammunition, also emphasized ammunition effectiveness and crew training as force multipliers that could partially offset numerical inferiority. The Leopard 1 main battle tank, developed by West Germany in the 1950s and entering service in 1965, incorporated design philosophies that reflected lessons learned through bitter experience. The tank prioritized mobility, reliability, and firepower over armor protection, recognizing that modern anti-tank weapons made heavy armor of questionable value against sophisticated ammunition. The Leopard 1 mounted a British-designed 105mm gun capable of firing advanced ammunition types, including armor-piercing, fin-stabilized discarding sabot rounds that represented the direct evolution of HVAP principles. The Leopard 1's emphasis on mechanical reliability and ease of maintenance directly reflected German recognition that the most technically sophisticated tank provided no combat value if it could not reach the battlefield or remain operational once engaged. German engineers who had struggled with Panther and Tiger mechanical unreliability throughout the war applied these hard-earned lessons to ensure the Leopard 1 could be maintained by conscript mechanics with limited training rather than requiring specialized technicians. This represented a fundamental philosophical shift from wartime German tank design. The Leopard 1 became one of the most successful tank designs of the Cold War era, serving with numerous armies and remaining in production for decades. Its success validated the design philosophy that prioritized practical effectiveness over theoretical performance specifications, a lesson purchased at terrible cost during World War II, when German tanks often achieved impressive specifications but failed to deliver proportional battlefield results due to mechanical unreliability and logistical unsustainability. The conclusion of World War II in Europe, marked by Germany's unconditional surrender on May 8, 1945, ended the immediate tactical need for HVAP ammunition against Panthers and Tigers. American ordnance officers systematically examining destroyed vehicles found clear evidence of HVAP penetrations on numerous wrecks, confirming the ammunition's effectiveness under favorable conditions, while documenting its limitations when conditions were less than ideal. Panthers hit by HVAP typically showed penetrations through the mantlet or turret face when struck at favorable angles, validating American tactical doctrine that emphasized creating favorable engagement geometry through maneuver. The heavily sloped glacis plate remained highly resistant to HVAP at most combat ranges, demonstrating the limitations of even advanced ammunition against well-designed armor when presented at extreme angles. This pattern validated tactical doctrine, emphasizing flanking maneuvers and combined arms operations rather than relying solely on improved ammunition to overcome armor advantages. Tigers examined after the war showed a different damage pattern. The flatter frontal armor proved vulnerable to HVAP at medium ranges when struck at favorable angles, though the variably thick mantlet remained problematic, with heavily protected sections still resistant even to tungsten penetrators. Side armor proved consistently vulnerable to HVAP at extended ranges, confirming that American crews who could achieve flanking positions possessed ammunition capable of defeating German heavy armor reliably. The comprehensive post-war analysis concluded that while HVAP meaningfully improved Sherman capabilities against heavy German armor, the truly decisive factors in Allied victory remained overwhelming numerical superiority. Vastly better logistics and supply infrastructure, complete air superiority that German forces could never challenge effectively, superior artillery support that provided fire on demand, and more effective operational doctrine that emphasized combined arms coordination rather than individual weapon system superiority. The transformation of American tank crews from mid-1944 to early 1945 reflected the cumulative impact of combat experience, improved equipment availability, and familiarity with specialized ammunition, including HVAP. Crews that landed in Normandy in June 1944 often felt genuinely apprehensive about facing German armor, particularly Panthers and Tigers that enjoyed significant advantages in armor protection and gun performance. This apprehension was entirely rational, given the material disadvantages American tanks faced against German heavy armor. By early 1945, after months of sustained combat, significant training improvements, increased availability of 76mm Shermans, and growing familiarity with HVAP ammunition capabilities and limitations, American tankers approached engagements far more confidently. This psychological shift had direct tactical consequences that affected combat outcomes as significantly as any material improvements. Confident crews fought more aggressively, took calculated risks when opportunities appeared, and exploited tactical advantages rather than operating defensively from positions of assumed inferiority. While HVAP ammunition alone did not create this transformation, which resulted from multiple factors developing simultaneously, its availability and proven effectiveness contributed meaningfully to improved American armored force morale and tactical performance. Crews who knew they possessed ammunition capable of threatening German heavy armor under favorable circumstances fought differently than crews who believed themselves helpless against superior enemy equipment. This psychological dimension of warfare, often overlooked in technical analyses that focus solely on measurable performance specifications, proved as important as any material factor in determining combat outcomes. The legacy of HVAP development continues influencing modern ammunition design 7 decades after the war's conclusion. American armor doctrine from 1945 onward consistently emphasized ammunition effectiveness as a critical component of tank design, recognizing that gun performance depended as much on ammunition characteristics as barrel length or muzzle velocity. Modern tank ammunition uses depleted uranium or tungsten alloy penetrators, materials chosen for essentially the same density and hardness properties that made tungsten carbide effective in World War II. The underlying principle remains constant across generations of ammunition development. Concentrate maximum kinetic energy into a small, extremely dense projectile moving at the highest achievable velocity. This fundamental physics has not changed since HVAP was first developed, though materials science and manufacturing techniques have advanced dramatically. The continuity from 1944 HVAP to present-day armor-piercing, fin-stabilized, discarding sabot ammunition illustrates how foundational lessons from World War II continue directly influencing military technology development. Soviet and later Russian tank ammunition development followed remarkably similar paths, independently recognizing that armor-piercing capability depends heavily on projectile material properties and kinetic energy delivery, rather than simply increasing caliber or explosive filler. The global tank ammunition industry traces its technological roots to the HVAP experience, where engineers first demonstrated conclusively that specialized ammunition could partially overcome armor protection advantages that would otherwise require mounting impossibly large guns. The principle that ammunition technology matters as much as gun size or armor thickness has been repeatedly validated through subsequent conflicts. During the Korean War, American 76mm Shermans, armed with HVAP ammunition, proved highly effective against North Korean T-34-85 tanks, achieving favorable exchange ratios despite the T-34-85's theoretical advantages in armor and gun performance. The difference came down to superior American crew training, better tactical employment, and critically, the availability of HVAP ammunition in quantities that had never been achieved during World War II. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.